Smile and learn.
Hello, friends. Today I'm here to talk to you about sound. Have you ever wondered what is sound? Today I'll explain it to you. Will you join me? Sound is produced when the vibrations of an object travel through a solid, liquid, or gaseous medium until they reach our ears. Sources of sound are objects, things, or materials that vibrate, producing sound. There are two types of sound. Natural, such as thunder, or artificial, which are produced by man-made objects. For example, a musical instrument, such as my guitar. Sound propagates in the shape of waves that travels in a straight line in all directions, and it travels faster in dense mediums. For example, sound travels 1,125 feet by air and about 4,862 feet by water in 1 second. Isn't it interesting that sound travels at different speeds depending on the medium it is in? Sounds have three main characteristics that help us differentiate them from each other. These characteristics are loudness, pitch, and timbre. I'll let you know more about them in depth. Loudness is energy that is produced by sound waves. If the loudness is high, then the sound will be loud. But if it is low, it will be low. The unit of measurement of loudness is a decibel. A normal conversation takes place at about 35 decibels, while a car horn is about 90 decibels. At 120 decibels and above, sounds can be dangerous to the ear. Some sounds that exceed this level are in an airplane taking off, or using a jackhammer. The second characteristic we'll talk about is pitch, which depends on how many vibrations or waves take place in each second. If the number of vibrations, also called frequency, is high, then the sound will be high-pitched. If the number is low, then the sound will be low. Our ear is only capable of hearing sounds between 20 Hz and 20,000 Hz. Sound frequencies below 20 Hz are too low to be heard, and we call them infrasound. However, if the frequency exceeds 20,000 Hz, we have ultrasound. This can only be heard by some animal species, such as dogs or bats. Isn't that amazing? The third characteristic of sound is timbre. It depends on its wave shape. And it allows us to distinguish sounds even if they have the same loudness and pitch. Timbre, for example, helps us to differentiate the sound between a stringed and a wind instrument. Have you ever heard of an echo? An echo is an acoustic phenomenon that occurs when a sound wave hits an obstacle and it is reflected back to us, causing us to hear the sound shortly thereafter, repeatedly. Let's try inside this cave. Echo!
See you later, alligator.
Ha 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 ha. Echoes are so much fun. That's all for today, friends. I'll be rehearsing for a while. See you soon.
Welcome back to Science Madness! In today's program, we are going to learn about magnetism. Have you ever wondered why magnets stick to the fridge and don't fall off? This happens thanks to a property called magnetism. Let's see what it's all about. Magnetism is the property some objects have that attracts other metallic elements, like iron. As you know, all matter has an electric charge. Normally, this charge is electrically neutral, which means there is an equal number of negative and positive charges. However, in some materials, this is not true, and this imbalance of charges causes attraction or repulsion. Magnets can be both natural and artificial. One of their main properties is the ability to attract objects made of iron and other metallic materials. This is called magnetism. Natural magnets are found in nature. An example is magnetite. Artificial magnets are made by humans from different metals, like iron or steel. So, what are the characteristics of magnets? Come with me to discover them. Magnets have two poles which we can find at their opposing ends. We call these ends the North Pole and the South Pole, and they generate a magnetic field. If we put two opposing poles together, they attract each other. This means that if we bring the North Pole of one magnet and the South Pole of another together, they attract each other. On the other hand, if we put two of the same poles together, they repel each other. Pretty interesting, right? But magnets aren't just used to hang the shopping list on the fridge. They can be used for many other things. Let's take a look at some examples. Digital storage devices such as hard disks and memory cards use magnetic properties to store data. Screens, speakers, and other electronic devices also have magnets inside them. They're everywhere. I'm sure you've probably seen magnets on the clasps of bags and purses before, right? Look closely. Did you know that compasses work thanks to magnets? Magnetism is very important in knowing our orientation and location. This is possible because our planet has a magnetic field that starts in the Earth's core, which is made up of metals such as iron and nickel, and extends through hundreds of miles of outer space. This magnetic field has a north and a south pole, just like magnets. Because of this, we can say that the Earth acts like a giant magnet. It moves the compass needle to the north and allows us to know where we are so we can move around without getting lost. Interesting, isn't it? Good job, my friends! I hope you like magnets as much as I do. See you in the next video. Bye-bye! Hi, everyone! Welcome to my show, Science Madness! Today, we're going to dive into the world of electricity. Thank you. We have some really cool activities planned, including some science experiments. I know. So get ready for an awesome episode on electricity. For the first part of the show, we asked some children from around the world to explain what they know about electricity. Let's connect with our first friend.
Hi guys. Electricity is something we need to power our electronic devices, such as televisions or my electric guitar.
Before electricity was invented, people used candles for light. Now, with just a push of a button, we can light up our houses. Not only that, with electricity, we can power trains and amusement park rides.
My teacher told us that we can create electricity by using the energy from natural resources such as water, oil, or even the sun.
Thanks guys. I think we learned a lot from our friends. As we saw, electricity is a type of energy we use to turn on lights or power our electronic devices. Electricity has become so important in our lives that we can't imagine living without it. As our last friend said, electricity can be produced in many different ways. Let's find out. We can use energy from natural resources like fossil fuels, wind, water, and the sun to create electricity. Let's take a look. Fossil fuels such as coal, gas, and oil are natural resources found beneath the Earth's surface. We burn these fossil fuels at power plants to boil large amounts of water. This produces steam that is powerful enough to turn a large turbine, which basically looks like a big egg beater. When the turbines turn, they activate a generator that produces electricity. But we have to be careful because producing electricity with fossil fuels is harmful to the environment. Another way we can get electricity is by using the force of the wind. In other words, wind energy. Have you ever seen wind turbines? When the wind blows and pushes the blades of the wind turbines in a circular motion, it also turns a shaft, which activates the generator, producing electricity. We can also get energy from the force of the water. Maybe you have seen a dam. It is a big wall built to collect large amounts of water. The water is pushed through pipes, which creates the pressure needed to turn the blades of the turbine, thus activating the generator and producing electricity. This type of energy is called hydroelectricity. Lastly, we will talk about the energy we can use from the sun. This is called solar energy. When it's a sunny day, the solar panels capture the solar energy from the sun and transform it into electricity. Solar panels can be found on buildings, cars, boats, and space satellites. There are more ways to produce electricity from these natural resources, but the ones we saw today are the most common. Once the electricity is created using these natural resources, it is then transported through cables and wires to our homes, schools, and workplaces, ready for us to use. Electricity can also be stored in batteries that we use to power our flashlights, mobile phones, or remote controls. Well, there you have it. Now we know where our electricity comes from. It's important to understand that electricity should not be wasted. Remember to turn off the lights and other electrical devices when they're not in use. Up next, we're going to discover types of electricity and circuits. Stay tuned for our next video. Hey friends! Welcome back to Science Madness, a program where we discover, learn, and experiment new things. In our last video, we learned what electricity was and where it came from. Today we're going to learn about types of electricity and circuits. Are you ready? Let's start with a couple of questions. Have you ever walked across a carpet and later felt a small shock when you touched an object?
Yes.
And have you ever brushed your hair for a while and noticed how it got stuck to your brush?
Yes.
Good, well this happens because of static electricity, meaning that an electric charge is created when objects rub against each other. So let me explain. All objects are made up of atoms that are impossible to see because they are super small. These atoms have different electric charges, positive or negative. When two objects rub against each other, they become charged with energy, and the negative charges move, creating an imbalance. We call this imbalance static electricity. Sometimes, static electricity causes two objects to stick together or attract to each other, such as hair and a brush when we comb our hair. The brush has more positive charges and the hair has more negative charges. Positive and negative charges really like each other. That means they attract each other. Whereas atoms with the same charge don't like each other at all, which is why you will notice that hairs want to separate from each other. This is because each strand of hair is negatively charged. When two objects have the same charge, either positive or negative, they either move away from each other or repel each other. Now we know why sometimes some objects give us a shock. It's because we send the excess electrical charge from one object to another. Now that we know what static electricity is, let's look at dynamic electricity. Static electricity only lasts a short time. Obviously, we can't use it to charge our cell phones or turn on a lamp. We need to obtain a different type of electricity using the natural resources around us, as I explained to you in our last video. The electricity we receive at home to run our electronic devices is called dynamic electricity. Dynamic electricity is the flow of electric charges. Just as water flows in a river, so do electrical charges in a cable. In order for electrical charges to flow continuously, we need a circuit. A circuit is a closed path in which electrical charges travel along. Circuits have two parts. The first is the source of electricity, which we discussed in the previous video, and the second corresponds to the materials that allow the flow of electric charges. I'm going to show you. Here we see an electric circuit inside this flashlight. There are two batteries, which are the source of electricity, and the wires that carry the electric charge to the bulb. If I turn on the switch, the electric charges begin to flow through the wires and the bulb emits light. If I turn off the switch, the electrical charges stop flowing and the bulb stops emitting light. This works the same as a drawbridge. When its parts are lowered, cars can go back on the road. The same is true for the electrical charges in a circuit. Alright guys, now that we've learned all about the types of electricity and circuits, let's see what you remember. An imbalance of positive and negative charges between two objects is called static electricity. Static electricity, that's it! And the flowing of electric charge is called dynamic electricity. Dynamic electricity, very good. Great job. See you at the next show. Don't miss it. See you soon. Welcome back to Science Madness! In today's program, we're going to learn more about electricity. We'll create an electrical circuit and we'll find out which materials are conductors and insulators. Are you ready? We will start by building an electrical circuit. which, as you know, is a closed path that electric charges flow through. I will need 2 wires, a light bulb, and a battery. We will attach one end of the wire to the light bulb and the other to one of the battery's end. I'll repeat the same steps with the other wire and voila! We've just created an electrical circuit. The electric charges flow from the battery to the light bulb through the wires, and as a result, the light bulb lights up. Isn't it impressive? If I disconnect this circuit, the electric current stops flowing and the light bulb turns off. When I reattach the wire, the light bulb turns back on. How cool is that? Let's make this more interesting. What would happen if I added this spoon to the circuit? Do you think the light bulb would still work? Would you like to make a bet? Ta-da! The light bulb came on! Amazing, isn't it? Just like the copper inside the wires, this spoon is made of metal, and metal is a great conductor of electricity. Silver, iron, or aluminum are examples of conductive metals. Conductive materials allow electrical charges to flow through them and therefore are the best materials to add to an electrical circuit. But conductive materials aren't only metals. Water, for example, is also a conductive material. Curious, isn't it? Let's try another type of material. Look at this rubber ducky. If we attach it to the circuit, what will happen? Will the light bulb turn on? Ooh, the light bulb didn't turn on. The little ducky is made of rubber, and rubber is an insulating material. Insulating materials do not allow electric charges to flow through them. That's why the light bulb didn't light up. Other materials such as paper, plastic, or glass are also insulators. As you know, electricity can be very dangerous. So insulating materials are used to protect us from it. For example, the outside of wires are made of plastic, and electricians' gloves are made of rubber. Well, I think that's it, friends. I hope you had fun and at the same time learned a lot of interesting things about electricity. See you soon!
Welcome back to Science Madness! In today's video, we're going to learn about a very special type of magnetism, electromagnetism. First, let's review what electricity is. Electricity is a physical phenomenon that occurs when there is movement of electrical charges in objects. This is called an electrical current. These electrical charges can be positive or negative. Now that we have reviewed what electricity is, do you remember what magnetism is? Magnetism is a very interesting property that some objects have. It causes them to attract metallic elements like iron. These objects are called magnets. They can be natural or artificial and have 2 magnetic poles, the North Pole and the South Pole. Have you ever used a compass to orient yourself? A compass uses a magnetized needle that always points to the Earth's magnetic North Pole, which allows us to locate ourselves on a map. And do you remember what a magnetic field is? Exactly! It is the space surrounding a magnet where its magnetic force acts. In other words, it is the space where a magnet can attract other metals. Now we are ready to learn what electromagnetism is. Here we go! Let's start with a bit of history. In the 19th century, a scientist named Hans Christian Ørsted discovered that when he brought a compass close to an electric charge, the compass needle didn't point north anymore. What do you think this meant? That's right! Electric currents produce a magnetic field. Wow! We call this relationship between electricity and magnetism electromagnetism. Let's see if you can guess what this is. It's an electromagnet! We can generate a magnetic field very easily thanks to electromagnets. This involves tuning a metal bar into a magnet by connecting it to an electric current, in this case a battery. To do this, we wind a wire of conductive material, such as copper, iron, or aluminum, around the metal bar. So why are we doing this? Remember how I told you earlier that electric currents generate magnetic fields? Well, this wire's magnetic field is very weak on its own, so by wrapping it around the metal bar in a spiral shape, we concentrate the magnetic field in a small area, which increases its power. When we turn on the electromagnet, the electric current starts to circulate, activating the magnetic field and attracting nearby metals. It's impressive, isn't it? We can also use electromagnets in a variety of ways. We can find them in bells or car brakes, but we can also find them in huge cranes they use to attract metal waste in landfills. Good job, friends. See you in the next episode. Bye-bye.
Hey friends, today we're going to talk about light. Yes, light. Have you ever thought about it? Did you know that light is a form of energy and that thanks to it, we can see objects using our sense of sight? Follow me to uncover many interesting facts about light. Light comes from natural or artificial light sources. One example of a natural light source is the sun. And one example of an artificial light source is a lighthouse. As I said before, light is a form of energy, and we call it luminous or light energy. Light energy can be transformed into other forms of energy such as electricity or heat. For example, solar panels can store light energy and convert it into electricity to run household appliances or to heat water for showers. Did you know that light travels in a straight line and in many directions at 186,000 miles per second? This is known as the speed of light, and it is a unit of measurement to calculate the distance between two very distant points, such as the distance between planets. We can both see objects that emit light and those that reflect it. Each object is composed of different materials that behave differently with light, and these can be transparent, translucent, and opaque. Transparent materials allow light to pass through them, allowing us to clearly see objects behind them. Glass is an example of a transparent material. Translucent materials are those that partially allow light to pass through, preventing us from seeing clearly what is behind them. For example, curtains. Finally, opaque materials are those that do not allow light to pass through and therefore do not let you see what is behind them, such as a wooden door. We have learned some very interesting facts about light, haven't we? See you soon. I'll tell you more about light next time. Bye! Hey friends! Today we're going to continue learning more facts about light. Do you know that light has many properties? Come with me to learn more. Let's start by talking about the main properties of light, which are reflection and refraction. Reflection. It occurs when light rays called incident rays collide with an object, and later, when these rays bounce in another direction, they are called reflected rays. We can differentiate between two types of reflection, specular and diffuse reflection. When every incident ray is reflected in the same direction, specular reflection occurs. This property allows us to see ourselves reflected in a mirror or shiny surface. I look great today. However, when rays are reflected in different directions, this is called diffuse reflection.
which is what allows us to differentiate some objects from others so we can appreciate every detail. Diffuse reflection allows us to know, for example, that this is a ball, and we can differentiate it from other objects. Now let's look at another property of light, refraction. Have you ever wondered why, when you put a straw in a glass of water, we see it differently than when it is outside water? This happens because of refraction. When light rays pass from one medium to another, for example from air to water, they change their speed and direction. This is how refraction happens. The light rays that reach an object are called incident rays, and the light rays that change their trajectory or velocity are called refracted rays. This property causes us to see objects differently, like when we look at an object through a magnifying glass. Refraction is the property we use to create lenses, which you can find, for example, in eyeglasses or camera lenses. Refraction is also the property that allows white light to be broken down into different colors. This phenomenon can be seen using a prism. When light rays reach the prism, they are broken down into different colors that make them up. Isaac Newton was the first to achieve this with an experiment done in the 17th century. Yes, it was that long ago. Can you think of any natural event where this phenomenon occurs? Rainbows are formed when sunlight passes through raindrops. Thanks to refraction, white light is converted into a colored beam containing red, orange, yellow, green, blue, and violet. Wow, we have learned so many interesting things about light, haven't we? I hope the next time you see a rainbow, you'll remember me. See you soon.
Let's find out what energy is, what its properties are, and what types of energy exist. Energy is anything that has the capacity to produce a change in matter. If you look around, you'll see that energy is present everywhere. For example, cars move thanks to energy produced by motor combustion. The blades of the mill start moving thanks to the energy produced by the wind. We can walk or jump thanks to the energy we get from food. You should know that energy can neither be created nor destroyed. Energy can only be transferred from one object to another. For example, energy in the air can be transformed in electricity, and this can be transformed in thermal energy to warm a room by means of a radiator. We obtain energy from two sources: renewable and non-renewable. Renewable energy refers to all those limitless energy sources present in nature, like wind, for example, sunlight, or sea waves. Non-renewable energy refers to the limited energy sources that we exhaust with use, like oil or coal. Energy possesses four fundamental properties you should know about. Energy transforms. For example, when we use a battery for a flashlight, the chemical energy in the battery transforms in electric energy. Energy is transferred from one object to another. For example, when we mix hot and cold water, thermal energy passes from hot water to cold water. Energy is transported and can move from one place to another. This way, energy travels through electric cables and reaches our houses. Energy can be stored. For example, mobile phone batteries are used for storing energy. Let's recap. Energy transforms, is transferred, and can also be transported and stored. Thermal energy, that is also called heat energy, is transferred with heat. Mechanical energy is created by two objects, owing to their movement. Electric energy is carried by electric currents. Chemical energy is found in substances like food or fuel. light energy that is present in the light. Eolic energy that comes from the wind. Or hydraulic energy, which we obtain thanks to the flow of water. It's easy to understand that energy is essential for life because it causes all changes to occur in the world around us. Renewable energy. We obtain energy from two different sources: renewable energy sources and non-renewable energy sources. Today we're going to learn about renewable energy sources. Renewable energy refers to all those limitless energy sources present in nature. The sun, the wind, the force of water, or the inner heat of the earth are examples of renewable energy sources. These energy sources are present in nature and are naturally replenished. That's why they never run out. These are some of the most well-known renewable energy types. Solar energy comes from the sun and reaches us as light and heat. For example, thanks to these solar panels, we can capture sunlight energy and transform it into thermal energy to heat water in this house. Eolic energy comes from the movement of air or the wind. For example, these windmills transform wind into electric energy. Tidal wave energy comes from the movement of sea waves or when tides change from high to low, and vice versa. Hydraulic energy is produced by the water we store in reservoirs or artificial lakes. Look at this dam! Water falls over from a high spot. Then, it flows through the hydroelectric factory, where the force of the water is transformed into electric energy. Geothermal energy is generated from the heat stored in the earth. This type of energy is used for heating a house or generating electricity, for example. Let's look at some of the main advantages of renewable energies. They are environmentally friendly because they don't emit CO2 or greenhouse effect gases. They are limitless because they are obtained from natural resources that don't run out and replenish naturally. They are safer for our health because they don't generate toxic residues harmful for people. There is no doubt that renewable energies have many advantages, but there are disadvantages as well. Renewable energy resources are not found everywhere in the world. Countries with shorter daylight hours cannot produce as much solar energy as other parts of the world. Obtaining renewable energy can be random or variable because it depends on natural phenomena that we cannot always predict. For example, the amount of rainfall. To reach the world energy objectives and help take care of the environment, it's indispensable to accelerate the transition to renewable energies. Non-renewable energy. We obtain energy from two different sources: renewable energy sources and non-renewable energy sources. Today we're going to learn about non-renewable energy sources. Non-renewable energy refers to the limited energy sources on the planet that don't replenish naturally. Coal, oil, natural gas, or nuclear energy are examples of non-renewable energy sources. In nature, there are limited resources of this type of energy. That's why they may run out with use. These are some of the most well-known non-renewable energy sources. Oil is found under the Earth's surface. It's a liquid substance formed by a mixture of hydrocarbons. Oil has a strong smell and dark color. Oil is used to produce fuels like gasoline or gas oil, which we use to power the engines of vehicles. Coal is a rock that is extracted from open-pit underground mines. It's a black substance formed by the fossilization of the dead remains of plants. When coal is burned, it produces heat. Natural gas is extracted from deposits found under the ground. We use natural gas to heat houses. Uranium is a chemical element extracted from underground shafts and mines. We use uranium to produce nuclear energy, which in its turn will later transform into electric energy. Non-renewable energies have disadvantages for the environment. For example, exhaust gases emit contamination gases in the atmosphere, which are harmful for the planet. As for nuclear energy, it is necessary to handle radioactive residues properly. When there's an accident related to non-renewable energy resources and residues, environmental catastrophes of great magnitude may occur, which are crucial for the Earth and all living beings. To reach the world energy objectives and help take care of the environment, it's indispensable to reduce the use of non-renewable energy resources and accelerate the transition towards renewable energies.
We've learned so much in just one video. Did you know there are many more videos? Imagine how much you could learn. Subscribe to the Smile and Learn educational channel to learn and have fun at the same time.